welcome back. We are continuing from where we left off in part 1. I left a little sticky note here in case you want to look at the CG Wiki Rubik's Cube. I left a link over here to Matt's article, and then I just put this in a box to keep things neat. So the next thing we want to do is we want to build an RBD simulation. So let's use a transform node, and this will just let us lift up cube, because at the moment it is sitting in the middle of our floor, and we want it to be a little bit higher so that it has somewhere to fall from. And we don't want it to go too high, but something like a value of 3 works perfectly fine. The next thing we need to do is we need to pick a frame at which we want this to fall. So if you imagine the whole animation, it's going to rotate a few times, do some things, and then fall down. As you can see on the screen in the original, that's what it does. And so I'm going to pick a frame of 100, and I'm going to use a time shift node to freeze this at 100. So if you take a look now, this is not, it has no longer has any animation, but I've frozen this at frame 100. And so now we can create an RBD bullet solver, but this bullet solver needs packed geometry, and at the moment we don't have that. And so in this copy to point, we can just pack an instance, and this will now create packed geometry. And in order to see this, I'm just middle mouse clicking to see these attributes. And if I pipe this in here, I can give myself a ground plane. So collisions, ground plane, and we can hit play and just see what we get. So now we get a cube that falls down, and it's a little uninteresting. And so let's try and make it a little bit more interesting for ourselves. The first thing we can do is create an attribute wrangle, and we're going to call this set v. And I'm using v as velocity, so we can say v at v, and I'm setting the velocity, and let's just give it a value. So I'm going to say set, and let's do a value of -3, and let's just take a look at what that does. So that just pushes it down to the floor a little bit faster, but again, it's still not very interesting. So I can add some more interest with a point velocity node. This will just let me add some curl noise to this. So what I need to do here is say keep incoming, so it keeps my velocity incoming. I'm just going to add an add node. This is just to visualize this. If I delete the geometry, I can see these points, and then I can visualize my velocity. So at the moment you can see my velocity is pointing straight down. And so what I want to do here is just add some curl noise, and now you can see that it gives it some nice random direction. So let's just increase the scale a little bit so that it's pushing it even more, and we can just use some random offsets here to make it even more random. So now if we take a look here, we can turn off our velocity visualizer and hit play. You can see that it looks a lot better. So even without this, it just kind of goes straight down, and it's pretty boring. And then when we add this in here, it gives it a really cool look where they kind of fall around and they fall on top of each other. But of course we want to build this up, and instead of just doing a reverse time where it kind of climbs on top of each other, I wanted to do something a little bit more dynamic. And so I'm going to use something from the motion operators or MOPS library, and that's called MOPS apply attributes. Now this is a plus node, and if you take a look at the MOPS website, there's a paid version and a free version. The free version is amazing. There's a host of nodes. If we take a look at MOPS, you can see there's a lot of nodes here, and most of these are free, but a few of them are called MOPS Plus, and these are separate nodes that are on a paid subscription, a yearly subscription. They very, very cool, and if you are doing a lot of motion graphics type stuff, these nodes and this toolkit is definitely worthwhile. The free one is a no-brainer. Definitely get it because it's free, and the paid one, if you find yourself using some of these tips and tricks, I would definitely suggest getting it. So we're going to use this MOPS apply attributes, and we will pipe it in. And in this force update, we wanted to update the position and the rotation. And if we scroll down to the bottom, we want the snap eye distance turned on, and we want this to be set to 1. And if you take a look, if you hover over it, gives you some helpful tools, and it says if enabled, once the object is within the snap distance of its goal, snap goal over the number of frames equal to the snap time. So you can see the snap time is 1. So when it's within a distance of 1, between there and there, it'll slowly kind of snap in. And what this will do is as it's going towards the goal, it will kind of snap into the place. But what we need to do now is we need to kind of set where this is going to get its information from. So we want to set up a second stream where we can kind of feed in some data so that it knows where the kind of goal target is. So let's take this and let's just say that this is going to be our goal target. We can set a null here, and we can say out target, and I will just make this black and then a little down arrow. And something else we need to do here is just use a MOPS extract attributes, and this is one of the free nodes, and it'll just extract the kind of packed, because this is packed geometry, it'll extract the packed data that we need, and we will extract the orient. And we also want to make sure that this is time shift, and so we can just copy this time shift, and over here we're going to set this to be 0 so that it's stuck on frame 1, so that when we move from here, it's going to fall down, it's going to go back to our original state. So we can now go into MOPS, and in this inputs, instead of the geometry, we can go to subpath, and we can use these backticks, and this just goes up different levels, and we can say out target, and then we're referencing this target here. So now we need a MOPS fall off or some sort of fall off to tell this MOPS apply attributes when we want to kind of go back to the original. So I'm going to use a MOPS shape fall off, and I'm going to start it at about frame maybe 52, and I want to grab my handle. I'm going to move this back, and I can also preview this fall off, and if I go in here and display as sprites, you can see now I can preview this, and as I go through it'll change their colors. So I want to start off around here. I'm going to set a keyframe here, and let's go to frame maybe 115, and then let's pull this through and set another keyframe. But now this is actually opposite to what we want. We want to reverse these keyframes so that it starts off as 0 on frame 52ish, and then on frame 115 we can drop in our keyframe. So now it's going from 0 to 1, and we can visualize that over here with our MOPS fall off. So it starts off at 0 and then it goes to 1. Okay, so let's turn off our preview fall off, and let's dive to our solver, and let's just take a look at what that looks like. So it falls down and then nothing happens, because what we need to do is we need to make sure that our MOPS fall off is actually carrying through. So we can just add our MOPS fall off into this attribute that it's going to bring in, and now when we hit play, it should be bringing in our MOPS attribute, and you can see now it's building it back up. So it falls down, and then once our MOPS attribute starts growing through here, it starts to rebuild itself. Now there are ways to do this without this paid version of MOPS, but it's very vex heavy. It's a lot of code because you have to take into account this pack geometry and prim intrinsics, and it's just a lot of stuff. And I found that this node is super easy. Just pop it in and it works. So I tend to use that a lot. So before we finish, let's do an RBD IO, and this will just let us cache out this simulation. And so I'm going to just set this to be RBD sim, and we'll set it at version 1, and we will sim 300 frames, and I am working at 24 frames per second, and I will simulate this. Now RBD is very fast, especially with such a simple scene. So this went really quickly, and now I have 300 frames of this cube. Now I don't need 300 frames because it basically finishes here, but for this project I'm working in 300 frames, so I will just do that. So that concludes part 2. I will see you in the next one, where we kind of dive into some vellum and making this look a lot fluffier and more fun.